everyone. Myself, Mrs. Lakshmi Patil. As we all are facing this pandemic situation, this is the only method for us to keep our teaching learning process on. So dear students, go through the online classes or your recorded classes or attend the live sessions, but make sure that you are studying, you are still learning. Okay, so this is my first class for the first PUC, Hydrocarbons chapter. As we all know that we have completed the alkanes concept. So today in this class, we will be studying about the alkenes. What are hydrocarbons now? The compounds which contain only carbon and hydrogen. Such organic compounds are called as hydrocarbons. In hydrocarbons, we need to study three concepts, that is alkanes, alkenes, alkynes. And we have already completed about alkanes, where we have studied nomenclature of the alkanes, preparation of the alkanes, chemical properties of the alkanes. Correct? So after alkanes, we will be going for the unsaturated hydrocarbons, that is alkenes and alkynes. In this session, we will start studying about alkenes. Alkenes are the hydrocarbons who have the general formula CnH2n. We have the general formula for the alkenes, CnH2n. And we have carbon-carbon double bond in the alkene. We have carbon-carbon double bond. Whereas in the alkane, we had carbon-carbon single bond, sigma bond. But here we will be having carbon-carbon double bond. One is sigma and one more is pi bond. Correct? So first concept what we have to study here is naming of the alkenes. We have to see how to name the alkenes, that is nomenclature of the alkenes by following the IUPAC rules. First, let us start the nomenclature. Let us start nomenclature of the alkenes. Let us see some examples. First example, CH2 double bond CH2. What is the rule of the IUPAC now? What are the rules of the IUPAC? First, we have to select the parent chain, that is a straight carbon chain. We have only two carbons here, so therefore this is my straight carbon chain. Number the carbon chain, carbon number 1 and carbon number 2. We have seen what are root words. Depending on the number of carbons in the parent chain, we have some root words. If you have only one carbon in the compound, what you are going to say? Meth. Meth is the root word used. If you have two carbons in the straight chain, you will be using eth. If you have 3 carbons, prop, 4 carbons, bute, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, 8 carbons, oct, 9 carbons, nan, and 10 is dec. So here we have only 2 carbons in the straight chain. So which root word you are going to use here? It is eth. It is a root word. It depends on the number of carbons present in the straight chain. This is my straight chain. I have only 2 carbons. So root word I will be using eth. Eth is the root word. Next, I have double bond between carbon number 1 and carbon number 2. So what is the suffix used for the double bond? It is ene, alkene. Fine. Here it will be ethene. It is ethene. Go for the second one. This is the root word and this is a suffix used. Root word depends on the number of carbons present in the straight chain. Suffix depends on whether we have single bond or double bond or triple bond. If you have single bond, you will use ane. If you have double bond, suffix will be ene. If you have triple bond, suffix will be ine. Okay? Go for the second example. CH3, CH, double bond, CH2. So here, this is my straight chain. This is my straight chain, parent chain. In parent chain, how many carbons do you have? Carbon 1, 2, 3. If you have 3 carbons in this straight chain, what is the root word used? It is prop. It is prop. Now, second rule, we have to number the straight chain now. Whether you will start it from the left hand side or from the right hand side. You will start it from the right hand side. Why? Because you need to give the lowest number for this double bond. You need to give lowest number for the double bond. For example, if I started from the right hand side, it will be carbon 1 and carbon 2 and carbon 3. If I started from the left hand side, 1, 2 and 3. Just observe, this double bond is getting 1 and 2 if I started from the right hand side. If I start numbering from the left hand side, the double bond is getting carbon number 2 and 3. So what is the rule? You have to give the lowest number. You have to give the smaller number for the double bond. So it is from the right hand side we have to number it, so that I can give the lowest number for the double bond. It is prop root word, and you have double bond between carbon 1 and carbon 2. You can even write it directly as propene, or you can write it as prop, that is 3 carbons, and double bond is between carbon 1 and 2. Use the smaller number, prop 1-ene. What is it? I have double bond between carbon number 1 and 2. I'll just use the smaller number, prop 1-ene, or directly you can say propene. Go for the third one, CH3, CH, double bond CH, CH3. Okay. See how many carbons do you have in the straight chain? This is your straight chain. Yes, this is my straight chain. This is a straight chain. From which side you are going to number it? You have to number it from the side where you are going to give the smaller number to the double bond. Started from the left hand side, 1, 2, 3, 4. Or started from the right hand side, carbon 1, 2, 3, 4. See, for the double bond, you are getting carbon number 2 or number 3. And if you started from the right hand side, 2 and 3, all same. Both the sides are saying same. Correct? So let it be from the left hand side. How many carbons do you have in the straight chain? It is 4 carbons. What is the root word used? It is bute. The root word used is bute. And where do you have the double bond here? Double bond is present between carbon number 2 and carbon number 3. So what you have to do? You have to use the smaller number. It is 2. Bute 2-ene. Bute is a root word. Ene is a suffix. Where you are going to use, why you are going to use that number 2? Because you have the double bond between carbon number 2 and carbon number 3. So you have to use the smaller number to say where you have the double bond. Bute is a 4 carbon chain you have. On the second carbon, that is between the second and third carbon, you have the double bond. So you are going to use name it as bute 2-ene. Get it? Go for the fourth example. That is CH3, CCH3, double bond CH2. So, follow the same rules again. Select the parent chain. 1, 2, 3. This is your parent chain. If not, 1, 2, 3. Second option. If not, 1, 2, 3. Which you have to select now. See, you have to select this parent chain, if not this parent chain. Why so? While selecting the parent chain, it is compulsory that you have to involve your double bond in the parent chain. You have to involve your double bond in the parent chain. Either you can go for this option, or you can go for this option. Started from here and use this carbon here. Okay, so let us take this as a straight chain, and as I said you have to give the lowest number for the double bond. Started from the right hand side, carbon 1, 2 and 3. See, on the second carbon you have some substituent present. What is the substituent name here? It is methyl. It is methyl. If you have CH4, it is methane. If you have CH3, it is methyl. So on the second carbon you have methyl. So say it. On the second carbon you have a methyl substituent present. And what is your parent chain? This is your parent chain where you have 3 carbons. So root word will be prop. Between carbon number 1 and carbon number 2 you have the double bond. Between carbon number 1 and carbon number 2 you have the double bond. So you use the smaller number to say it. 1-ene. Or directly you can write it as propene. if you are getting 1, you can neglect it. You can directly write it as a propene and it is understood. You have the double bond between 1 and 2. Getting? Go for the next example. Fifth one. Go for the fifth example. CH double bond CCH3 okay. So which is your parent chain here? This is my parent chain. In the parent chain, how many carbons do you have? 1, 2, 3, 4, 5. Number it. I'll number it from the left hand side because I have to give the smaller number for the double bond. I have to give smaller number for the double bond. On the second carbon again you have some substituent here. What is substituent present? It is methyl. So it is 2-methyl. In the parent chain you have the 5 carbons. So it will be pent. And you have the double bond between carbon 1 and carbon 2. So you can write it as 1-ene. 2-methyl pent 1-ene. Go for sixth one. Go for the sixth one. Okay. Here, this is my parent chain. This is my parent chain. Start numbering it from the left hand side. Why left hand side? I have to give the smaller number to the double bond. 1, 2, 3, 4 and 5. If this is my parent chain, these two are the substituents present on the parent chain. See what are the substituents present here? Methyl groups. How many methyl groups you have? 2 methyl groups. And where you have on carbon 2 and carbon 3. Say it. On carbon 2 and on carbon 3, you have 2 methyl groups. It is dimethyl. 2, 3 dimethyl, and parent chain you have the 5 carbons. So you will be having the root word as pent. 2, 3 dimethyl pent, and you have the double bond between carbon 2 and carbon 3. So which number you are going to use? Smaller number, 2-ene. 2, 3 dimethyl pent 2-ene is the IUPAC name of this particular alkene. Go for the next example. Go for the next example. How many carbons you have in the straight chain? It is 5 carbons. You are going to number it from the left side or right side. It is from the right hand side. 1, 2, 3, 4 and 5. If I number it from the left hand side, 1, 2, 3 and 4. I would have got carbon 3 and carbon 4 for the double bond. But the rule says you have to give the smaller number for the double bond. So I will start it from the right hand side. Now, how many carbons you have in the parent chain? 5 carbons. So what root word you are going to use? Pent. You will be using pent as a root word. And where do you have the double bond here? Between carbon number 2 and carbon number 3. You are going to use the smaller number. Pent 2-ene. You will be using pent 2-ene. So the IUPAC name is pent 2-ene. Go for the next example, 8th one. I'll give you the name now. 4-methyl hex 1-ene. IUPAC name of the compound is 4-methyl hex 1-ene. So how will you write the structure of the compound? Hex, it is a root word. It is saying you that you are having 6 carbons in a parent chain. So directly write first 6 carbons in a parent chain with a single bond. 3, 4, 5, 6 carbons. Correct? Number it. 1, 2, 3, 4, 5, 6. 4-methyl. That means on the 4th carbon you are having a methyl substituent. 4-methyl hex 1-ene. 1-ene. What does it saying? Between 1 and 2 you are having the double bond. Between carbon number 1 and carbon number 2 you are having the double bond. So rest of the valences, write it CH2. Here you will be having 1H. Here you will be having 2H. Even here 2H. Here CH3. Right? 4-methyl hex 1-ene. Write the 9th one. Pent 3-ene. That is pent 3-ene. Pent is a root word which is saying you are having the 5 carbons in the straight chain. Take 5 carbons in the straight chain. Okay. Number those. Carbon 1, 2, 3, 4 and 5. Pent 3-ene. What is it saying you? 3-ene. Between 3 and 4th carbon you are having the double bond. That is pent 3-ene. Write the valences of the carbon. CH3, CH2, 1 hydrogen here and here CH3. It is pent 3-ene. Write the last 10th example. Write the 10th example. Okay. Take down the 10th example. And now select the parent chain. Select the parent chain. Here if you just count the carbon numbers, carbon 1, 2, 3, 4, 5. This is the one option where you can select your parent chain. If not, it is 1, 2, 3, 4. If you just see here, it is C2H5. Do not get confused. I can even write this as CH2, CH3. If not, I can write it as C2H5. Correct? Both are same. Ethyl group. It is 1, 2, 3, 4, 5. First option might be your parent chain. If it is not, then go for the next one. 1, 2, 3, 4, 5 and a 6. Parent chain will always be the longer chain in the given compound. So definitely this will be my parent chain. This is going to be my parent chain, which is having 6 carbons in it. So number the parent chain. Whether you are going to number it from here, just count, select, check it. 1, 2, 3 and 4 you are going to get for the double bond. 3 and 4 for the double bond. Come from this side. 1, 2, 3 and a 4. Both same. So start it from this side. Carbon 1, 2, 3, 4, carbon 5 and carbon 6. On the 4th carbon you got your methyl group again as a substituent. What is it? 4-methyl. 4-methyl. And in the parent chain, how many carbons do you have? You have 6 carbons. So what will be the root word? It is hex. 4-methyl hex. And you have the double bond between carbon number 3 and carbon number 4. So you are going to use the number, smaller number, 3-ene. 4-methyl hex 3-ene. 4-methyl hex 3-ene. 4-methyl hex 3-ene. I hope you understood how to name the organic compounds, that is alkenes, by following the IUPAC rules. Next is, we have to count the sigma and pi bonds in the given alkene. How many sigma bonds you have and how many pi bonds you have to calculate. Now, CH2, it is a ethene. How many sigma and how many pi bonds you have in this? To calculate that, first write the expanded form of this compound. That is double bond C, 1 hydrogen here and 1 more here. You have 2 hydrogens on the both the carbons. Now start counting it. You have sigma bond 1, 2, 3, 4, 5. You have 5 sigma bonds. You have 5 sigma bonds and only 1 pi bond. 5 sigma bond and 1 pi bond. Do the same thing for all the examples, whatever you have now. Go for CH3, CH, double bond, CH2. It is propene, correct? Am I right? Yeah, it is propene, or you can call it as a prop-1-ene. First write the expanded form of it. CH3, carbon with single hydrogen, double bond carbon with 2 hydrogens. Now start counting the sigma bond. Here you have 1, 2, 3, 4, 5, 6, 7, 8. So you have total 8 sigma bonds and 1 pi bond. You have 8 sigma bond and 1 pi bond. Go for the next example. Go for the next example. What was it? Let us take okay. Let us take but-2-ene. Correct? It is but-2-ene. In this, try to calculate the number of sigma and pi bonds. First, write the structure. Carbon with 3 hydrogens here. Carbon with 3 hydrogens. Carbon with single hydrogen and double bond carbon with single hydrogen. And the terminal carbon with the 3 hydrogens. Now calculate the sigma bond here. You have 1 sigma, 2, 3. Here you have 4, 5, 6, 7, 8, 9, 10, 11. So you have total 11 sigma bonds and you have 1 pi bond here. You have 1 pi bond. So this is how you have to calculate the sigma and pi bonds in the given alkene. Take the fourth example. CH3, CCH3, double bond CH2. What is IUPAC name of this compound? It is 2-methyl-prop-1-ene. Correct? So calculate the number of sigma and pi bonds in this. Write the structure, that is CH3, single bond C, double bond CH2. Here you have 1 more carbon with 3 hydrogens. Now start calculating your sigma bonds and pi bonds. Here you have 1 sigma, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total you have 11 sigma bonds here and you have 1 pi bond. You have 11 sigma bond and 1 pi bond in 2-methyl-prop-1-ene. 2-methyl-prop-1-ene. Take one more example. It is pent-3-ene. CH3, CH2, C double bond, CH, CH3. It is pent 1, 2, 3, 4, 5. Pent 1, 2, 3, 4, 5. So it is numbering from the right hand side. 1, 2, 3, 4, 5. It will be pent-2-ene. I have taken pent-2-ene. Now you calculate the number of sigma and pi bonds in this. Carbon with 3 hydrogens. Carbon with 2 hydrogen. 1 more carbon. Double bond carbon, single bond hydrogen. CH3. Correct? So now calculate the sigma bond and pi bond. 1 sigma, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 sigma bonds and you have 1 pi bond. 14 sigma bond and 1 pi bond. Getting? So this is how we have to calculate the sigma and pi bonds in the given alkene. So that was about your nomenclature of the alkenes and calculating the number of sigma and pi bonds in the given alkene. So the next concept is isomerism. It is isomerism. Isomerism. What are isomers? Isomers which are having the organic compounds which have the same chemical formula but different structural arrangement, you call them as isomers. Correct? You will be having the same chemical formula but the arrangement of the molecules will be different. So such compounds you call them as isomers, and the phenomenon you call it as a isomerism. In this phenomenon isomerism, we have two types of isomers. One is geometrical isomers and one more is structural isomers. In this we have one is structural isomerism phenomenon, or the second one is geometrical isomers. You have structural isomers and geometrical isomers. In this again you have the chain isomers and position isomers. Chain and position, and here you have cis isomers and trans isomers. Cis and trans isomers. Let me take one example and explain you what are structural isomers and what are geometrical isomers. Take one example. First example. Take one example, that is CH3 CH double bond CH2 CH single bond CH3. Take this compound. The name of the compound is butene. Correct? 1, 2, 3, 4. Butene. I can write the same chemical formula but different structural arrangement by writing it as CH2 single double bond CH single bond CH2 and CH3. Please count down the formula or write the formula here. You have 4 carbons C4, 3 hydrogens 4, 5 and 8 C4H8. CnH2n is the general formula for your alkenes, therefore you got C4H8. Try to calculate here. Again here you have C4, 2, 3, 5 and 8. It is also C4H8. I have written the same chemical formula but I have just changed its structural formula, structural arrangement. Can I write it again like this? CH3, CH3, double bond CH, CH3. Did I go wrong? Yes. It is CH2. Carbon 1, 2, 3, 4. Calculate the hydrogens. 3, 6, 8. C4H8. So I have same chemical formula but different structural arrangement. Therefore, I call them as structural isomers and the phenomenon is called as structural isomerism. I have same chemical formula but I have written it in a different structural arrangement. Correct? And what is this chain isomers? See, example, the first, second, third are an example of chain isomers. Here you have the straight chain. Here you have the branched chain. Correct? Here you have the straight chain and here I have branched it. So I have two different types of structural arrangement, that is chain and position. Here I have straight chain and here I have a branched chain. Different in their arrangement of the carbons. It is straight chain and here it is a branched chain. So you call it as a chain isomers. And the next one is a position isomers. See, where do you have the double bond? Here you have the double bond between carbon number 2 and carbon number 3. And here you have double bond between carbon number 1 and carbon number 2. These two you call them as a position isomers. These two you call them as a position isomers, where you have the double bond position different here. Here you have double bond between carbon number 2 and carbon number 3. Here you have the position of double bond between carbon 1 and carbon 2. If you just concentrate here, again it is present between 1 and 2. So this is an example for chain isomers and position isomers. Then what about this geometrical isomers? Let us take an example for that. The same example. Here we'll take again butene and try to arrange it in cis and trans isomer. So what are geometrical isomers? Geometrical isomers, there will be a different spatial arrangement of the atoms across the carbon-carbon double bond. There will be different spatial arrangement of the atoms across the double bond, the carbon-carbon double bond. Take an example, that is CH3, CH, double bond CH, CH3. Again I have taken but2ene. How will I arrange it now? See, across the double bond, your spatial arrangement of the atoms will be different. Such isomers, you call them as a geometrical isomers. Definition is different spatial arrangement of the atoms across the carbon-carbon double bond. You call them as geometrical isomers. So I have to write cis and trans form of this particular example. Let me take carbon-carbon double bond here. Fine. Arrangement across this double bond should be different. So I have two hydrogens on this carbon. Let me take it above. And I have CH3 on again the same two carbons. Correct? If you just concentrate here, I have taken similar atom or molecule on the same side, hydrogen above, both the methyl groups below. This particular arrangement where you have the similar molecules to one side, you call it as a cis. If not, arrange it like this. Take one hydrogen above and one CH3 above. Take one hydrogen below and one CH3 below. Where you have different atoms at the same side. You call this arrangement as a trans isomers. Different spatial arrangement of the atoms or groups across the carbon-carbon double bond, you call it as a geometrical isomers. And here we have two types of the geometrical isomers, that is cis and trans. What is it? The arrangement across this double bond, it will be different for cis and trans. If it is cis, the same groups will be at same side. CH3, CH3 below the carbon-carbon double bond. Hydrogen, hydrogen above. But here if you just observe, one CH3 is below and one CH3 is above. There is a different groups present on the same side. Similar groups present on the same side. Cis and trans. These are the two geometrical isomers what we have to study. And this was all about your nomenclature of the alkenes, calculating the sigma and pi bonds, and the introduction of isomers. What are isomers? The compounds which have the same chemical formula but different structural arrangement, you call them as isomers. And the phenomenon, you call it as isomerism. We have two types of isomers, structural isomers and geometrical isomer. What are structural isomers? That is chain and position structure. These are the two types of structural isomers we have. Here, chain means either you will be having a straight chain or you will be having a branched chain. Position position of the carbon-carbon double bond will be different, but the chemical formula remains same. The position of the double bond only varies. Fine. And next is geometrical isomers, in which I have two types of geometrical isomers, that is cis and trans. What is geometrical isomers? Different spatial arrangement of the atoms or the molecules or the groups across the carbon-carbon double bond. Different spatial arrangement of the atoms or the molecules or groups across the carbon-carbon double bond, you call them as geometrical isomers. If the same groups are present on the same side of the carbon-carbon double bond, you call them as cis. If the different groups are present on the same side of the carbon-carbon double bond, you call it as a trans. This is all about nomenclature and isomers. And the next concept what we have to study is preparation of the alkenes. Now we got to know how to name the alkenes by using the IUPAC rule. We got to know how to calculate the sigma and pi bonds in the alkene. We know what are isomers and two types of isomers. Next is we have to prepare these alkanes starting from different reagents. Correct? The next concept is preparation of alkenes.